Hello class, welcome to Algebra Lesson 4.4, which is all about linear inequalities in two variables. By the end of this lesson, you should be able to graph solutions to linear inequalities in two variables. So let's start with example 1, which is, does xy satisfy the inequality? So what all that means is if I give you, like this point, does the point 3,2 make this inequality true? The way I would check that is I have 3, 2. Remember, in our ordered pairs, it's always x comma y. So I'm going to plug 3 in for x. So I'm going to say 3 times 3 plus 5 times, and then my y is 2. I want to know, is that less than or equal to 11? 3 times 3 is 9, plus 5 times 2 is 10. So 19, is that less than or equal to 11? No. So this would not be a solution to the inequality. So all you would do is say no. Why don't you go ahead and try this one on your own? Good luck. Okay, for this one, you had y is greater than 7x plus 2, and then you had the 0.34, so hopefully you plugged 4 in for y and 3 in for x. Then you would end up with 4 is greater than 23, which is not true. So you would say no. All right, then example 2, graph a two-variable inequality. You'll notice that there's nothing else on this slide, and the reason for that is because I'm actually going to teach you using IXL. So I'm going to just switch over here really quickly to show you what you will be doing with your assignments even. All right, so here is where we are going to practice graphing two variable inequalities, linear inequalities. So the first one we're given is graph this inequality, and we're told y is greater than -2. So first things first, y is greater than -2. I'm going to go to where y is -2, and I'm going to put a dot. And then remember, when you just have y, this line's kind of a special case. It's where it's just horizontal. So you could click any of these places, because if I think about this, the point here, that's 1, -2, so my y is still -2. If I went here, the point is 2, -2, 3, -2, 4, -2, 5, -2, 6, -2. You can see it's always -2. So that's why this line is my y is greater than -2. Now, if we think about when we graphed linear inequalities, or just inequalities back on number lines, whenever it was the greater than without the or equal to, you had an open circle. So there's a special case for this here too. Since it's just y is greater than 2, -2, I'm going to click on this line to turn it into a dashed line. That's the same as an open circle, okay? So now I've graphed the line y equals -2, but this isn't an equal sign. This is y is greater than -2. So I want to find which part of the graph is greater than -2. That would be everything up top here. So I'm going to click to shade it in. So when you're graphing linear inequalities with two variables, it's just like graphing with like slope-intercept form, except you're going to shade, and you're also going to change it from solid to dashed lines. Okay, so I'm going to click submit. I have the first one right. Now I have another special case. I have x is less than or equal to 4. So I'm going to go to where x equals 4. I'm going to put a dot, and then x stays 4 along this vertical line, right? Because this point would be 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, and so on, or 4, -1, 4, -2. So I can click anywhere on this line, and then I can see I have an x is less than or equal to. So when you have the or equal to, you leave it as the solid line, but if you accidentally click and make it dashed, all you have to do is click again to make it a solid line. If you have the wrong kind of line, say you have a dashed line here instead of a solid line, it is going to be marked wrong on IXL. Okay, now let's think about this. X is less than or equal to -4. So x is less than going to the left on this side. So I'm going to click to shade that in, click submit. Awesome. Now I finally have y and x. So if I treat this as slope-intercept form, y equals mx plus b. I don't have a plus b, right? There's nothing written there, so my y-intercept is 0. Then my slope is 2, so I'm going to go up 2 to the right 1 because it's positive. Then I have less than or equal to. I'm going to leave it as a solid line. Now this is where shading gets to be a little trickier, but not too much. When you have the two variables, all you're going to do is you're going to pick a point that is not on your line. So if I pick a point that's not on my line, let's say I pick 1, 0. So this point right here where the pointer finger of my cursor is pointing, 1, 0. That means x equals 1, y equals 0. So if I plug that in, I'd have y is 0. So 0 is greater than or equal to 2 times 1. 2 times 1 is 2. So I have 0 is greater than or equal to 2. Is that true? Is 0 greater than 2? Greater than or equal to 2? It is not. So that means that this point does not meet the requirements, so I need to shade on the other side of the line. Okay, so I need to make sure that that point that I just picked is not shaded. So I'm going to click submit. Okay, I'm going to try another one. I have y equals negative 5x. Again, there's no plus b. There's no plus any number, so it's 0. My slope is negative 5, so I'm going to go down 5 to the right 1. And then it's just less than, so I'm going to change it to the dashed line. And now I'm going to pick another point to try. So this time I'm going to pick 1, 1. I like picking numbers with zeros and ones because it tends to be easier. So I have 1 is less than negative 5. Is that true? Is 1 less than negative 5? Nope. So I have to go to here's my 0.11 I tested. That's not true. I have to go to the other side of the line and shade there. All right, here's another one. Y equals negative 4x plus 3. This time I start at my y-intercept of 3. I have a slope of negative 4. So I go down 4 to the right 1. And then it's just greater than, so I change it to dashed. And then I test a point. This time, my line isn't going through the point 0, 0. So I like to use 0, 0 whenever the line is not going through it. Because then it's easy. I have 0 is greater than, this is 0 plus 3. So 0 is greater than 3. Is that true? No. So I would shade over here. Maybe you picked a different point. Maybe you picked like 4, 0 or something. Maybe you picked 4, 0. So then 0 would be your y. And then negative 4 times 4 is negative 16. Negative 16 plus 3 is negative 13. So I would have 0 is greater than negative 13, and that's true. So I would know that this point needs to be shaded, which I already figured out with my 0.00. But I wanted to show you kind of another way you could get it, okay? So again, I'm going to plot a point at 2. I have a slope of 5. I'm going to go up 5 to the right 1. And then again, I have less than or equal to, so I'm going to leave it as a solid line. And then I'm going to plug in 0, 0. So is 0 less than or equal to 2? Because 5 times 0 is 0. So 0 plus 2 is 2. 0 less than or equal to 2? It is less than. So I'm going to shade the part with 0, 0. Submit. So you can see I've gotten 6 questions correct and I'm already at a score of 49. For your homework, you're going to get up to a score of 70, so 1 ribbon. And then in the other IXL that you're going to do, it's just testing those points. So do these things make it true? This is actually the problem that you did earlier. And the answer was no. So you would hit submit. And then it clearly just glitched right there. My bad. Here is your concept summary for this lesson. If you have questions, please don't hesitate to reach out for some help and ask. I am more than happy to help you. Have a wonderful day.